The state of the art in the literature right now cannot get us to an L4, L5 driving. We are inventing that. We're writing the playbook. So it's not as easy as getting some building blocks from the literature and putting it together. It's really writing that playbook.
From EE Tech Media, this is Moore's Lobby, where engineers gather to talk all about circuits. I'm Dave Finch. Today in the lobby, I am joined by Mo ElShenawy, Senior Vice President of Engineering at Cruise, for a refreshingly realistic and positive conversation around fully autonomous vehicles. If you're sitting in gridlock traffic right now, or even heavy traffic, or maybe the road is wide open and you're driving, but you'd rather be just knocking out those last few emails so you can enjoy your evening at home. Well, there's a company in San Francisco who's figuring this out for us. Cruise is building the world's most advanced self-driving, all-electric vehicles. According to the company, their aim is to safely connect people to the places, things, and experiences they care about, which is a pretty humble way of stating we are actively transforming transportation. As the first all-electric, zero-emissions fleet, Cruise believes that self-driving cars, when deployed at scale, have the potential to save millions of lives, reduce emissions, reshape our physical environment, help restore the health of the planet, give back billions of hours of time, and restore freedom of movement. If you think this sounds awesome, you're not the only one. In fact, General Motors believes so much in Cruise that they purchased the company 5 years ago for $1 billion. The acquisition is said to position GM strategically against Toyota and, perhaps more tangentially, companies like Uber and Waymo. So if you're Cruise, with such an ambitious goal and considering ultra-high stakes such as human lives and safer, healthier environment, who do you choose to lead your engineering efforts? Who might be capable of solving the most important engineering challenges of our generation? Who's got what it takes to orchestrate the collective expertise of hundreds of engineers working across an entire spectrum of disciplines? Who's going to solve the problems that nobody else has solved yet? How about someone who engenders the virtues of a Cruise autonomous vehicle? Someone who is extremely intelligent, visionary, uncompromisingly committed to safety, and of course, self-driven. Mo ElShenawy is Senior Vice President of Engineering at Cruise. Altogether, Mo's engineering staff are roughly 750 in number. Collectively, his organization is responsible for autonomous vehicle development, product and mapping engineering, data and machine learning platforms, on-premise and cloud infrastructure, engineering productivity, product as a service, and a handful of other disciplines, all working in harmony to develop a safe, scalable, autonomous vehicle lineup. The key word here is scalable. Of course, Mo is no stranger to starting small and scaling rapidly, or for that matter, starting at scale and catalyzing new growth. Earlier in his career, Mo was head of global technology at a little e-commerce company you may have heard of called Amazon, a role which he was well prepared for, by the way, having earned his engineering stripes as the software lead for a firm that produced custom enterprise-class software solutions for Fortune 100 companies. Mo, it's a real honor to have you join me today because, like the technology you are creating, a career trajectory such as yours is nothing that happens by accident. You know, it takes some solid building blocks, and not unlike a safe autonomous vehicle, two of those blocks are intelligence and vision. So, speaking to your intelligence, was it always technology for you? Like, in other words, as a kid, what motivated you? Like, what did you gravitate towards?
Yeah, absolutely. I think the common theme is just the curiosity and passion, and I've been driven throughout my career, like from early ages, and without dating myself too much, it was like even like getting into electric engineering and computer science in the first place was influenced by that childhood period, where it's like just growing up with, I still remember being fascinated with this little electronic chessboards going to date myself here. It's like you
Yeah.
playing a computer on an electronic physical chessboard. And I remember opening this up and staring at it and trying to read as much as possible. It was not as easy as getting literature right now, but just reading about
Right.
search algorithms. It was not neural nets at the time, right? And getting into like Commodore 64s and like all this good stuff just centered my career around just really impact and learning curiosity. And I think that's the common trajectory. It just that's been driving me. I've been very passionate about being a lifelong learner and having an impact. And that's the one common theme that I had across my career.
How did your parents nurture that? Did you come from a family of engineers, or did they say, well, hey, it looks like Mo's pretty interested in this chess thing, this chess game? Or
Yeah, no, that's a great question. It was, no, I did not come from a family of engineers. My dad spent his life in the special forces, and my mom was also a working professional. So I was very inspired by their work ethics, and that's something I'm very grateful for. But no, they tried to nourish that. As I said, like if you remember, like without dating myself too much, Commodore 64s and Sinclair 128, these were expensive computers at the time, equivalent of
yes,
like $1,500 here or something. And it comes
yes,
with a basic interpreter. It's pretty sad to think back at what you were able to not do with these things, but it shows the
there
level.
was no end to,
Right.
no end to what you can't do.
Exactly right. But it was fascinating at the time, and it triggers that learning curiosity. And I remember reading a lot. And at the time, it was we were coming out of the winter of AI. If you remember, the second winter of AI. After a lot of doubt of what AI and neural nets can do or cannot do, and just like trying to embrace that again, that helped a ton, right? So my parents were very supportive as far as like just helping me become who I am and nourishing that passion. And I'm very grateful for that.
The barrier to entry in our day growing up was not nearly as low as it is now to get into things.
Yeah.
So if you were into something, you were really into it because it was
Takes effort.
trying to find documentation resources.
Yep.
But some people get really tunnel vision on just the technology, the circuits, the bits. And it seems like what has been a consistent theme throughout your career has been seeing the bigger picture around technology. So if I can make the machine do this, well, there's a business case over here. And suddenly it's, is this something that you always had a mind for, or did you have mentors and kind of coaches as you were coming up through university and in your first, people who would explain to you, it's one thing to understand the design, the machine, the technology. It's another thing to understand how the world needs the technology.
That's a great question. As I said, I was always driven by impact. So that's something that I think it came in naturally because the end game of touching people's life positively is a great thing. But I would definitely had a lot of great mentors, and I've been fortunate throughout my experience. What piqued my curiosity earlier, I remember I was working on this is very, very long time ago, a very complicated project contracting for the US Army, without getting into too much details, but it involved electronics and hydraulics rules, and C++ at the time was extremely hard, right? And I remember my peers next to me were working on an inventory system written in Visual Basic at the time. It was extremely simple, but the impact of it was tremendous. It was licensed to like a very large entity at millions of dollars at the time, had a huge impact. And it starts triggering me that it's just like, technology for tech's sake, sometimes people fall into that trap, right? And that driven me to get my MBA, not to change my career at all. My purpose of getting my MBA was to actually try to understand a little better and polish the technology and try to apply it better, and then started the journey of having startups. And I was very determined, like that my end goal from my startups was really not wealth building as much as it learning and capability building. I was very determined about setting that goal and optimizing for it. So I think that helped shape my career quite a bit.
I like that phrase you just used, technology for technology's sake, because that is sort of a trap. I don't mean to make back-to-back engineering puns, but the other thing that people tend to do, another trap that you were able to avoid was people short-circuiting. I see the technology, I want to get to wealth, just bang, bang. You know?
Yep.
I would like to take a quick review here, and I'm doing this with the help of your LinkedIn profile. It starts off, mid-90s with software engineer, late 90s, I should say, at a organization called Asset Technology Group, followed by another organization, SCH Business Solutions, and very quickly, it's like August 1997. I started as a software engineer.
Yep.
In a very short amount of time, you become the highest ranking sort of head of engineering, director of software engineering at SCH Business Solutions. The next jump, all of a sudden, you're at Amazon.
Right. It seems fast on a LinkedIn profile. To me, it's an eternity, right? It's and it was more of a deliberate decision, right? Like you've touched on it spot on. Like the shortcuts, in my opinion, the analogy is similar to like taking shortcuts in your code on your solution. There's always a shortcut, a short-term solution that is usually least passive resistance, but not the best term, long-term. Early on my career, I was very deliberate of staying on the IC track. And I think I had opportunities, and it was appealing to look around you and find your peers jumping off early into the leadership track, which is a great thing, and advancing in their career much earlier. But my philosophy was I really wanted to build that foundation in knowledge and get the habits, the working habits, and understanding what does it mean to be an engineer throughout the ranks. So SCH was a smaller company. S Technology Group was also like a company that operates internationally. And throughout these two experiences, I was exposed to a vast set of problems that are very diverse. And I wanted to stay in the IC track as much as possible. When SCH started, we started with 2 engineers, myself and someone else, and wrote like millions of lines of code and ended up being, used by a lot of Fortune 50 companies, their key tax solutions. And that helped me a ton. Although the company itself was small, but working with Fortune 50 companies to actually understand their needs and implement critical solutions with big data problems at the time was fascinating. And I think that helped build a very solid foundation that helped me move into Amazon after that. And I was, of course, lucky to experience like 2 different roles there. And then from there, I would say the jump into Cruise was the most fulfilling in my career, especially like given the challenges we're having today and the great mission that we're set to do, which is just fascinating to be able to have the opportunity even to have that much impact on humanity and be part of, a mission that wants to really change transportation to the better and be more equitable, more sustainable, much safer, and serves communities a lot better than the current system. So that was a very fortunate career move for me.
Hey everybody, it's Dave. This segment of Moore's Lobby is sponsored by Orion Fans. Orion Fans, a division of Knight Electronics, is a global manufacturer of standard and custom AC, DC, and EC fans, harsh environment fans, fan accessories, fan trays, and blowers. Orion Fans supplies quality engineered and competitively priced cooling products to EV manufacturers and other OEMs worldwide. For more information, visit orionfans.com. Welcome back. I'm here with Mo ElShenawy, who is leading the engineering efforts at Cruise to produce ultra-safe and commercially viable self-driving automobiles. Since he was a child, Mo has always instinctually followed his passions and interests, never taking on more than he could handle, but never passing up the right opportunities to create big somethings out of nothing. Cruise could be described as a tech startup, albeit one that has to exist within the dizzying corporate structure of a behemoth like General Motors. For El-Shinawi, harmonizing the cultures of tech startup and big automotive is all in a day's work. if you're at a small organization, you're at whether it's a tech startup or a very small, very lean incubator, whatever the case may be, like you said, there aren't 250 other engineers who can write your 3,000 lines of code that are going to be used by Fortune 50 companies all around the world.
Right.
It's you. And if your code doesn't perform, doesn't work, well, what are we doing here? Like, you know,
you stay up till 4 a.m. and you work and you work hard through it. That's what you do.
But you have to bring the goods. It's on your shoulders. And as a young engineer, you can't not perform. And so, like you said, building this base, this understanding, this deep understanding of not only the technology, but then you do that around the business case for the technology. You work your way through Amazon, and now when you're in a position to sort of take the helm at Cruise, you've had a wealth of experiences both in an enormous corporate setting and in a very small lean operation. How have those two different professional settings shaped you now and how you're running things at Cruise and the decisions you're making?
That's a super relevant question, because honestly, up till Cruise, I've always decoupled these two words, at least in my mind. I thought they don't exist. I thought the company, the unicorn that would have the best of both worlds, don't exist. And that's why I was optimizing to like run my own startups, because I love taking things from 0 to 1 and making an impact and moving quickly.
Yeah.
But also working in a big corporation or big tech gives you that unique ability of scaling and know what it means to have 100 million customers and work with billions of transactions at a high scale, right? And Cruise is really the best of both worlds. To me, it was fascinating to see a company that still have that startup tech DNA, moves very fast but responsibly, at the same time backed up by billions of dollars from trusted partners and investors, that kind of validates its mission and the approach we're taking. And it really combines the best of both worlds. As we can get deeper into like the challenges, I'm happy to like just dive into like what does it mean to work with the challenges we're facing right now. Our approach at Cruise is also unique in its nature. Like, we're very determined in starting from the hardest problem first. That's why we're operating in San Francisco, right? Just working in an area where, especially in a solution like ours that is mainly deep learning heavy or machine learning heavy, it's all about data. It's all about the variety of the data and the quality of the data. And just taking an approach, a bold approach like ours, which might take longer to resolve on the first time, but much faster to scale to other cities, is fascinating, right? Because at San Francisco, just to give you like a few examples, just imagine the problem we're set to do. I'm going to take a detour a little bit, but like some of my friends would ask, was like, isn't that equivalent to like me teaching my kids how to drive? I was like, well, yeah, that's maybe the maneuver planning part of the equation. You're forgetting the human evolution part of the equation, how the brain evolved to perceive the world around us and to predict everything that's going to happen, right? And at San Francisco, we go through 20,000 plus intersection every week. We see thousands of cut-ins and lane takeovers and double park maneuvers, and you see 16 times more cyclists. You see 40 times more construction zones. In general, you see 50 times more challenging situation than if you were to operate in a suburb somewhere, right? That gives us this faster learning rate. And now imagine like just something that we see hundreds of times every day, to have your car come in and reason with, in a very narrow lane with an oncoming car, for example, to reason for occlusion and for oncoming traffic and go around the DPV and then take an unprotected left turn, but also try to reason for the gaps and predict it and reason for a pedestrian crossing. That's so many problems that we're trying to solve at once. And it just helps us really build a solution that is well generalized and easier to scale to other cities.
Do you have a wealth of models in terms of that basic human intelligence that we've just acquired and taken for granted? Even the quote unquote dumbest drivers can still get their car from point A to point B? Or are you building these yourself?
There is no playbook for AV. Just I want to make sure that there is a big difference between solving for L4, L5. And that's what
Yeah.
we mean, and that's what we're after here, versus solving a very advanced driving assistance systems. That's a very different thing. It's different in many different aspects. But the key thing is that you always rely on a driver backup behind the wheel to take over in the 0.01% of the cases, the edge cases, right? That's a very different problem space, and it informs our architecture, our principle guided ways in building an AV from the ground up. And we're very fortunate to have partnership with both GM and Honda to be able to do that at scale and do it in a competitive advantage way. But that's a different problem. It informs sensor placement. It informs sensor selection differently. And it informs how our models act differently, how we treat uncertainty, how we treat generalization differently. So these models you're referring to, the state of the art in the literature right now cannot get us to an L4, L5 driving. We are inventing that. We're writing the playbook. So it's not as easy as getting some building blocks from the literature and putting it together. It's really writing that playbook. It's pushing the boundaries and the state of the art on perceiving the world around us, on predicting actors, and doing this on a very low footprint compute and high latency, like very low latency as well, is an additional challenge.
Can you take me through this technology for, we'll say, an autonomous vehicle? I understand some of the basics of just an electrified vehicle, like those things, battery management, that sort of thing. But autonomous vehicles, we start thinking about sensors, and a phrase that now people are familiar with that they probably weren't before, LiDAR. And is that a big viable option? Is there something better? What are some of the essential building blocks from a hardware and technology standpoint that you're looking at currently? Yeah, that's a great question. And again, it comes back to the mission we're set to do, right? If you're trying to change the face of transportation and build a truly superior than human service, a complete autonomous driving service, it informs all of these questions. So it starts with, of course, the vehicle design and the sensor suites and their placement. And we rely on 3 different modalities and variations of them as well. And that's because, again, we are targeting L4, L5. So radars and articulating radars, long-term and short-term, is something that is known, of course. Computer vision and state-of-the-art cameras, high-definition cameras, and LiDARs are all viable options for us. And we rely on all 3 modalities. And then it comes into this is basically the raw sensor inputs for perceiving the world around you. And you get this in and you can fuse it. Like there is early fusion and late fusion theories that we have, we're working with both of them actually, but at the end of the day, the first building block here is perception, perceiving the world around you. What is really happening, right? Then you go from that into tracking the world around you as well. Now that you've perceived the world around you and you know exactly how the different scene is composed of, what is the free space, where's the pedestrians and cars and what's happening, start tracking the same objects across time is a very important aspect as well, and tracking through occlusion and understanding that, which leads into predicting what every actor in this complex scene I've described. It's not really a complex scene in San Francisco, but any complex scene, trying to at the same time predict what's the 100+ actors around you in the scene is going to do over the next n number of seconds, and that n changes based on the actors in focus versus not, and what's their impact on. Then from there, you shift into maneuver planning. Okay, now that you've understood the world around you, what is that nominal path that I take to fulfill my mission to eventually get me from point A to point B? But it cannot be taken in a vacuum. It takes in almost a combined joint calculation with prediction, because your actions are going to inform other actors on the scene's actions as well. So it ties back into prediction. So I have this joint prediction planning engine that performs the maneuver. And of course, this can't be hypothetical, right? You're taking vehicle dynamics and low-level controls into the equation, right? It's like your maneuver, if you're on a steep hill that is wet, is very different if you're in a flat, sunny, dry road, right? It's like the actuation of the maneuver itself varies, and tires dynamic and vehicle dynamics and all that is taken in consideration.
putting all these things together, and a lot more, of course. Like I skipped over localization and calibration and mapping for just simplicity, but there is just a whole ecosystem that needs to come together to provide that almost general intelligence of superior human driving.
Yeah, my nose is starting to bleed because there's just so much that you have to. I've been in traffic now for, let's see, I've been in traffic for 27 years, essentially, right? I was 16 when I got my license. I'm 43. So I will say that very rarely do I look around and really get a good sense that the people around me are considering the impact of their decisions on what everybody else is going to, whether they're driving 90 miles an hour on the interstate or 10 miles an hour. So perceiving what's going on around you is the first step, obviously, in this intelligence, this decision making around, all right, I see 80 to 120 different actors in this particular moment in time. I also know that the light just turned green. It's a left arrow. This thing it's a very precious amount of time, the left arrow. I'm going to go through the intersection quickly. Well, the amount of data is changing so rapidly.
Yeah, we are very fortunate to have the opportunity to design and engineer and build a truly autonomous driving vehicle from the ground up. And we're very fortunate to have Honda and GM on our core to do that with, right? Because we of course have some external suppliers, and that's been out there. But what we're experimenting with right now, what we're driving in the streets right now, is not what we're going to be producing at scale. The Origin, which we've exposed the first time back in January 2020, that's the vehicle that we're going to be driving at scale in partnership with GM, of course, on manufacturing. So there's a lot of state of the art technology going on there that we can disclose, but I'll tell you that it is designed basically to answer exactly, you've touched on this earlier. Our goal is not to barely exceed human driving and just plateau there. We're designing a system to by far be superior than the current transportation system, period. And not stop or plateau at just barely better than human driving, because that's not like a very exciting mission. It's like we want to continue to evolve, and the fact that right now humans make a lot of mistakes, you're absolutely right. And the goal is to, of course, be much more superior than that, and continue to advance and fill that product experience gap.
You see 30,000 car accidents probably a year, just in your own area, your own county, right, that you live in. None of them are newsworthy. None of them make the front page. Well, an autonomous vehicle, hits a light pole, and all of a sudden every news outlet's covering it, saying like, "Oh, the robot cars don't work." Yeah. Is it sort of unfair that we're expecting autonomous vehicles to be like 10 times better, safer drivers than humans, just simply because it is an artificial technology?
It's a great question. I think it's really a good area to discuss. I personally think it's a good thing to have that high bar of trust. It is a trust race, right? And we need to earn that trust race. I welcome that kind of scrutiny, and I think we need to be like extremely careful and very deliberate in our rollout approach, right? And this is not only for Cruise, for anyone else working in the industry. Everyone is motivated by a good cause, but our approach to get there needs to be earned, right? We need to prove and get the communities to embrace this and be patient about it, because it's not tech for tech's sake. It's not a tech race. It's a trust race at the end of the day. So it's understandable and it's welcomed, and I'm glad we're getting out of the trough of disillusionment to an extent, at least, to like just going from expecting that this is not gonna work altogether to like, okay, yeah, this is actually gonna work. It's a matter of time. It's a matter of when, not if, and we need to be very deliberate about the goals we are set to do here.
Okay, that's a very reassuring answer. Hey everybody, it's Dave. This segment is brought to you by Newark. Farnell operates as Newark in North America. Newark is a high-service distributor of technology products, services, and solutions for electronic system design, maintenance, and repair. Newark has developed many industry firsts that save precious time for our design engineer customers, such as the first online community for engineers, Element 14. We continue to bring the latest technologies to market, from development tools that speed up the design process to modular devices that engineers can quickly and easily build into their devices, and the latest in easy-to-deploy artificial intelligence. For more info, please visit www.farnell.com/Newark. In 2020, San Francisco-based Cruise unveiled the Origin, an all-electric self-driving shared vehicle designed, as stated by the company, to completely rethink the role of single-occupant, human-driven, gasoline-powered cars and the unacceptable status quo they have created for our transportation system. But how does a company begin to design for safety when the proposition is removing the driver from the driver's seat? How much data has to be generated, distributed, and processed in real time to make self-driving automobiles a viable product for the mass market? How do you develop the test environments? Where do you test it? Cruise's Mo ElShenawy is here with me in the lobby to explain just some of the solutions to technical challenges that the Origin represents, and how his own track record of critical decision-making influences the company's safety-centric approach to product development. I'm curious, is machine learning in an automotive application substantially different from how you would approach machine learning when it comes to making good financial transaction decisions or financial technology, that sort of thing?
Yeah, absolutely. And it's centered around that safety critical mission again. It's very different when you're experimenting in a very controlled, tight stage environment, where if you're working on a pricing model for an e-commerce site, or if you're working on an advertisement site, that's something that you can easily mimic and simulate much, much easier. It's all virtual, right? When you go down to the real world, and when you're working on a safety critical mission where there is no room for error, there's just like simply you cannot have mistakes, and it's a very different game, right? So and then creating the CI/CD in this case becomes a very different challenge. By the way, the continuous integration, continuous deployment. What I meant by CI/CD is like to allow our engineers and software engineers, it's all about agility and about trying fast and experimentation to provide that world. Although you're working in a very controlled, dynamic, uncontrolled dynamic environment, which is the real world, how do you, couple these two words of creating a safe, continuously integration, continuous deployment, continuous improvement environment? At the same time, it's a very critical, safety critical mission. So you have like to comb through any changes or any software changes that's going through the car in a way that guarantees safety, and in a way that guarantees that the impact of the change is going to be realized as expected. So that comes with a lot of complexity.
Yeah, let's dive into that, because like you said, the robotics is the other piece of this, that you have the luxury of starting from scratch and building something like this. Are you designing for almost like a seamless experience between ML and the robotics?
Yeah.
What have been the challenges that you've overcome just to date in getting these systems not only performing well on their own, but then performing as a system of systems?
Yeah, spot on. That's exactly right. It's at the end of the day, we're designing one system that has to be much safer than human, right? Than human performance. And accordingly, AI and robotics, while they can have their own sub KPIs and sub-tuned, at the end of the day, it's all about this continuous integration and creating an ecosystem for our engineers from the ground up that helps them. It's almost as if you're creating a development platform for AVs, for AI and robotics. And that's a very different than anything existing right now in the market. We have to create that from the ground up. All the toolings that our engineers need to analyze the massive sets of data, the petabytes that we're receiving every day, and be able to like zone down into the areas of interest, or to automatically and continuously label data of interest for us. We have a continuous learning machine, which is like automatically label things that are that we need for our models to be tuned and perform at a higher level, for example. creating a pipeline that allows for millions of labels of human-assisted labeling, whether it's via fully automatically or semi-supervised. That's just something. All these little pieces has to come together to create an ecosystem of tools to bridge that gap between experimentation and at the same time working on an end-to-end safety critical system. And it happens at a very massive scale too. And testing and simulation is a very big part of that system.
Testing and simulation, again, it's almost like aerospace and that sort of testing and simulation where you're testing an environment that hasn't been tested for yet.
Right.
or technical considerations. All right. Do you have the support of policymakers and lawmakers, like people at the federal government level looking at this and saying, here's how we're going to feel good about your testing results? Or are they looking at you and saying, companies such as you, and saying, you tell us how these things need to be tested?
No, we're working very closely with local officials, and our government affairs teams have been doing a great job being transparent. We believe transparency is a key aspect here that would drive high performance in general, right? So our government affairs teams have been working very closely with local officials and receiving a driverless permit recently, for example, and testing that in San Francisco. We were the first company to try this really in a heavy urban dense environment. Was a validation and another example of something that we've worked very, very hard to earn for like 2 million miles of autonomous driving testing in San Francisco and multiple months of testing on GM private road facilities leads to that. But the teams are working very closely with local officials to define this together and be transparent about what we're doing. The safety and testing rigor we're putting upon ourselves is extremely high. We not only validate everything in a virtual environment and continuously validate that. Just to give you like an idea of the scale and how important this to us is, like we run hundreds of compute CPU and GPU hours, hundreds of years of compute CPU and GPU hours per day, to make sure that every change, because we receive hundreds of changes from hundreds of engineers every day, right? Just they're all merging their changes, and you want to make sure that every change by itself is safe, and then all the combination of all the changes by themselves are safe. And you want to do that in a very well controlled simulated environment that have a variety of exposure to our road exposure. And this is again back to the advantage of driving in a city like San Francisco, is that you leverage the real world exposure to create both realistic scenarios and scenarios that you've never seen before as well, that you never wish to see on the street. But we take this extremely serious, right? And this goes through multiple levels of testing, even after the offline testing to like on-road testing and so on.
That's the only way to scale is to be able to manage all of these things and scale. Not only, I guess anybody can scale given enough time, but scale in a way that is commercially viable.
Yes.
Scale the way that the companies like GM and Honda need to be able to scale for a product line to stay, in their portfolio, we'll say.
Right.
I know I have to be respectful of your time, and I see I have 13 minutes, although I have at least 4 more hours of questions for you because
I'm happy to go over a little bit. But yeah.
No.
Not 4 hours, though.
Yeah, that's right. Oh, gee, the editorial team didn't tell you that this was going to be a 5-hour interview. I'm shocked. Hey, it's Dave. Our final segment is brought to you by Coilcraft. Headquartered in Cary, Illinois, Coilcraft has been a leader in the design, manufacture, and distribution of high-performance magnetic components, including RF chip inductors, power magnetics, and filters, since 1945. In addition to the industry's largest selection of standard off-the-shelf components, we also design and build custom magnetics to meet your precise requirements. For more info, please visit www.coilcraft.com. We are back with Mo ElShenawy from Cruise and talking about solving some enormous challenges from the ground up. one of the themes clearly in your career and in your life has been, let me be extremely good at what I do before I look and solve that problem over there. Another theme that I'm noticing is once you've gotten that comfort level with your skills and capabilities, you're taking like non-linear next big steps and tackling bigger and bigger and bigger problems with a lot of confidence. So one of the challenges that you're tackling right now with Cruise is one that impacts all of us, which is climate change and being more responsible with our environmental resources. Cruise, as I understand it, is developing a zero emissions vehicle. Right. Have you always been conscious of being sort of environmentally responsible in this way? Or is this something that's sort of becoming interesting to you now that you are in the automotive space?
That's a great question. And I wish I can give you the ideal answer that I've been aware of this since young age. No, I have not. Mm-hmm. Just to be completely humble and vulnerable. This was not top of mind for me growing up as an engineer. And you probably know the time back early 90s, it was not top of mind. Although it was top of mind for me recent in my career. And before even moving to Cruise, sustainability was a big factor in working on re-commerce on Amazon, for example. All the merchandise coming back to Amazon has a big sustainability footprint. But for Cruise specifically, this is at the core of our mission. When we're talking safety here, we don't only mean safety of our passengers in the car or pedestrians on the road. We mean safety of the planet. And we know that, greenhouse gas emissions from the current transportation model is an extreme big problem, and we're very centered and we're very purpose driven to solve that. So not only we have an electric fleet vehicles, but it's all charged from 100% renewable energy too. So like these things are super important for us, and the best part about it is that we know that solving for this in San Francisco first, and then scaling to multiple cities around the globe, and is going to really have an impact, and it's going to provide a value propositions that would, as I said, make us earn that trust rate, and trust rates for countries and communities to seek this technology, this kind of superior transportation, whether it's delivery or rideshare service, that would really change things to the better. We have, as you mentioned, there's across the globe, there's 3,000 people that die every day in car accidents. There is cars are parked 95% of the time. They're taking up to 3 parking spaces. They are defacing the communities and cities in general. And it is an inequitable service to start with. Like low-income families spend up to 30% of their disposable income on transportation, right? The entire ecosystem is flawed, and we know it's not okay to just keep the status quo. So we're very purpose-driven to change that at scale.
You're somebody who's standing sort of at the precipice of completely transforming how human beings move around. You're standing at the precipice of transforming mobility for mankind. It's a big deal. It's a big deal for the environment. Like, these are not small little changes that will happen. Last year, when they did the first COVID shutdowns here in the United States, I live in Denver, and I remember it was only a matter of a couple days before the brown haze that typically hovers over Denver completely disappeared. And if you didn't need any more empirical evidence than that, how important these technologies are. Yeah. So you're standing at the precipice of not only reinventing mobility and transportation, improving quality of life in a potentially equitable way now. What is standing between achieving that on a global scale and where you are right now? Is there an enormous gap in front of you?
Well, I wanna first say that I'm humbled, but you're saying it in a way that makes me personally even more worried. I'm not doing this alone, right? I have more thousands of people shoulder to shoulder, right? We have a very engaged founders and CEO and super experienced people. And we're very lucky to have a fortune of investors backing up, or of OEM partnerships, with a tech titan like Microsoft, just to tackle this problem alone, right? So it's it is indeed a very big challenge. At the same time, I have thousands of very, very smart and driven people that are uniquely aligned on a very crisp, clear mission to get there, right? So that is an incredible tailwind. You're not at this alone at all. You have a tremendous network of support and a lot of brains, a lot of IQ power behind it, and that gives us a ton of confidence, right? We're building this at scale, and we're at it as a sustainable long-term race, and it's a trust race. So, the journey starts when we start commercialization. This is not the end of the journey. This is the beginning of the journey, right? There's a very, very long path to get to this global scale. We're talking about to be everywhere in the world, and that's what we're determined to do. But right now, we're very happy with our continuous and accelerated progress, as proven by the latest milestones that were all over the press, and we're very focused to, at the same time, have our safety as a gating factor. Right? We're not pressured by a timetable. This is not a tech race. We're only focused on safety. And when we empirically are confident about our safety capabilities, which is very, very close to, then we're going to be able to launch, but launch in a deliberate and methodical method, again, that would make sure that we give people the chance to adapt the technology, embrace it, understand it, and earn that trust race.
How long will it be before I'm driving around in one, or not driving around in one, I should say? Riding around in one.
The not driving around is the key word. We want to give people the billions of hours. Just imagine that aspect on economic prosperity alone and how that changes people's lives, just to give back. Like, most people spend more than their average vacation driving, right? So as I said, we're very close, and we've been continuously improving. We're not only measuring our rate of progress, we're measuring how our rate of progress keeps accelerating. So these are all great signs, right? And we're very motivated, as I said before, by the mission, and we want to get there fast, but we will get there safer, and we will get there safer than the current system, and that's the key thing. So once we surpass that superior human performance level, we'll be able to deliberately deploy in a controlled fashion, and we're not very far away from that. Again, I just want to be humble here and say that there's thousands of engineers and partners in general in my team and outside of my team working tirelessly on this problem, and it takes a lot, right? There is a lot more than what meets the eye, right? People think of self-driving cars and they think of the models that run on the car, but there is a network of tremendous set of invention that's happening behind the scenes right now that will push the state of the art and will benefit other industries. Building that dev platform for IoT and robotics, AI in general, is a tremendous thing. The scale of how we operate, ingesting multiple petabytes a day of data and analyzing those on the fly. Just think of, again, your best show, and you can upload that to our cloud provider networks in less than a second. We have our own fiber link networks, and there's just a ton of things that's happening behind the scenes. We have thousands of data pipelines that are running automatically so that we can, label things based on discrepancies that we see on the road. And there's just, it is super exciting. It is really that intersection between impact and between learning and great technology that I'm very fortunate to be, again, part of. And, again, as I said, there's so many smart people working on this, and I'm very blessed to be part of that generation that's changing the world.
We see all the benefits to humanity that come out of the space program here in the United States, the space race. And is it fair to say that what you're doing right now in transportation is almost like a better evolution of the space race, in the sense that it's actually things that benefit us 100% on Earth?
Right. I used that analogy before, actually. I mean, I wouldn't say it's better, but there's definitely similarities. Like, the space race has caused tremendous advances in telecommunication and medicine and many other industries. And as I said, similar to what we're doing right now. Every engineer who's part of this ecosystem is pushing the boundaries, whether it's on the infrastructure side or in the embedded system, vehicle connectivities, or the robotic side or the AI side. You're pushing the state of the art. You're you're unlocking pieces of the puzzle that would not only benefit self-driving, but other technologies in the future. So definitely there is a parallel path between the two.
Man, it's got to be so much fun in your position to work with those thousands of highly talented engineers who are bringing so many great innovations to the table and making them happen. It's got to be exciting.
Absolutely.
So, okay, this is my one dumb, foolish question, and then I'll let you go. Is there any chance that you would entertain the idea of inventing artificial intelligence that actually simulates road rage and aggressive drivers between autonomous vehicles so they could try to outman each other on the highways? Is that anywhere on the horizon?
First of all, I would note that none of your questions were foolish or dumb. I think that we truly embrace that all-inclusive environment where we entertain a lot more edge case questions than the one you asked, by the way. But of course, this is not for like to deploy it on the road. But back to the simulation environment, like there is definitely a huge benefit of running in a very complex urban environment like what we see on the road in San Francisco, and that informs how our synthetic data is generated and inform how our test exposures are. But benefits of the simulation is to also have this parametric sim sweep of edge cases, that is maybe inspired with things we see on the road or things we never see on the road, right?
Oh, wow.
This is a huge benefit. We run 2 million simulations a day, right? When we keep expanding our simulation footprints, and a lot of these simulations are very hard edge cases. This is where reinforcement learning can play a role as well. And some of the scenarios in these parametric sim sweeps or the reinforcement learning, more almost of experimentation learning, could be very edge hypothetical cases. It's important to stress test the safety of the system in all conditions.
Oh my gosh. That a totally legitimate answer to a completely ridiculous. I hadn't even thought of that. You do have to design for, not everybody's going to own one of these.
Exactly right.
Yeah, that's exactly right. Wow, I never even thought of it that way.
Yeah.
Oh. All right. Well, let me tell you something. I'm glad you're the one solving these problems, because my armchair observation here is that you're the right guy to be doing it.
Again, I'm humbled, and I'm part of a large ecosystem working with many talented people to solve this.
This is tremendous. Man, thank you so much for your time. This
was a lot of fun, Dave. I really enjoyed this.
I'm glad. Me too, man. And hopefully we can do this again soon. Last thing, where do you hope you'll be 12 months from now in the development of all this?
We have, as I said, we have plans. We're very confident in these plans. All the indications of progress show that we're going to be ahead of these plans. We have great partnerships with Walmart, for example, for piloting with the delivery. And we're very determined on starting again a small-scale rideshare applications, but we will be there when we're safe, right? So I'm very cautious into sending the message to our engineers and everyone working on this is that safety is our gating factor. It is a trust trait, and in 12 months, it will be there when our safety determines. But we're very, very optimistic of our current projectile right now.
All right, I want to thank Mo ElShenawy for making time to chat with me today. Be sure to subscribe to Moore's Lobby on any of the major podcast platforms, including Apple, Spotify, Google, to enjoy new episodes every 2 weeks with industry experts from world-renowned companies who join us to chat about leading-edge technology and engineering topics. You can also follow us and catch prior episodes on allaboutscircuits.com. Thanks for listening.